I hear that music. I keep expecting Robin Hood to swing out of a tree somewhere. Dr. Bill Dees from Louisiana Tech joins us now. We're going to do some fun things with science. Well, we're going to do some things. We'll find out if they're going to be fun.
Well, of course it'll be fun.
Okay,
it's all fun, isn't it? What do we have here, Dave?
A rectangle.
We each have a rectangle, and
White
whose
paper.
rectangle is the larger?
They're both rectangles or same
They're
size?
both identical in size.
Identical
Okay,
rectangles.
now, you're going to make a cylinder, and I'm going to make a cylinder. But you're going to fold your paper like that and make a short, fat cylinder, right? And I'm going to fold mine like this and make a tall, slender cylinder.
But we're using the same size.
Same size piece of paper.
Give me a little tape here.
All right. Well, here
I don't want anybody to think that I've cheated on this.
Right. Okay.
Okay.
Now, what we're going to do then is
I hope Gigi's watching this because she doesn't know a lot about science.
Once we have our cylinders made, we're going to do a little experiment with them. Okay. If I can get mine done.
Darn, this is kind of hard to make it come out just perfect.
I wish I'd given you this one because this one's a lot harder.
Look at that.
Did you get it?
Look at that. Nothing like a good close-up.
Mine's close enough.
From
All
2
right.
miles.
So yours is short and fat, and mine's tall and slender.
We're talking about our cylinders.
Our cylinders, right. Okay, now,
what
we're going to do is fill your cylinder with salt.
Okay.
Okay, and so we're going to put it on the tray here and gradually and hopefully slowly and completely fill it with just everyday table salt. Of course, we could use sand for this.
But it'd be less expensive.
Right.
And we go all out to try to go the beach.
Well, I had to work chemistry in here somehow, and this is a chemical. Salt's a chemical, all right.
Well,
okay.
Sand's a something.
Sand's a chemical too, you're right.
Okay.
Oh, now I want to dump the rest of that in here.
Okay.
Okay, now, that cylinder is made from exactly the same material as this one.
And same size.
And they're the same size.
Right.
So, even though this one's twice as tall as that one, I forgot to mention that, the rectangles originally were 10 centimeters wide and 20 centimeters long. So
it's
twice as long as
2 to 1 ratio.
Okay,
there.
right.
Okay.
So now what we're going to do is compare the volume of these two cylinders. We're going to take the salt that completely fills your cylinder.
All right.
And
pour it back
into our container.
Which is empty.
Right.
Started out being empty.
Yes, it was empty.
We need a funnel to do this. I can
Yes,
see.
it looks like we do, doesn't it? Okay. Some of it.
I'm trying to help.
Salt's cheap. Salt's cheap.
Salt's cheap. Besides what we get around here, we just blow off on the floor.
All right, so now what do you think? Made from the same, which one is going to have a larger volume?
Mine has a larger volume.
Larger volume? You think so?
I don't know.
Which one has the larger surface area?
Same surface
They
area.
have exactly the same surface area.
Exactly the same surface.
So,
on the hole right here. I wish everybody could see Gigi and Rex. Everybody's just there.
They're making fun of us, aren't they?
No, they're not making fun of us. They are.
All right, now look at this.
Yeah, you're pouring salt all over my hand. That's one thing. Good night.
All right, so you were right. Your cylinder does have a much larger volume than my cylinder does.
It really does.
Okay.
But even though they're made from exactly the same
now that's
chip.
surprising to a lot of people, especially young school-age children. And in fact, a lot of, depending on their developmental stage, a young child will think just because this container is taller, it will hold more than a short container. Okay.
Right.
And there's a certain area or level of development when they can make that distinction that they get to. And now, why do we want to do this, though?
Well, we wanted to do this because we're demonstrating that we use the same size sheet of paper, but it depends upon the configuration of what the volume
Now,
is
when did you first talk about volumes of cylinders or whatever in school?
Oh,
you remember?
gosh, it's been several years ago.
5th, 6th, 7th grade?
Probably.
Okay. And when I had it, what my teacher did, they drew a circle on the board, okay, and they talked about the diameter of that circle.
Right.
And they said, okay, the circumference, which we represent for C, and they started putting all these equations on the board.
Right.
Is the diameter times a ratio called pi, all right? And of course, half the diameter is the radius, etc. And so I had to just memorize all these relationships.
Right.
Okay. And so
area
the same thing,
is pi r squared.
Right. Now, to calculate the volume of a cylinder, you take the area of the base of the cylinder and multiply times the height.
Right.
Okay. And so I just had to memorize that, and I got no gut feeling for what that meant.
Right.
But you and I have a common experience here by investigating the volume of these two cylinders.
That's an easy project
And so,
to do.
and now, when we go to the blackboard or to the class and start talking about the equations, they mean a little more. Now notice for the volume of the cylinder is equal to pi times the radius squared
Times the height.
times the height. Now, this cylinder is twice as high, has twice the height as that cylinder, but the volume was much less, right?
Right.
And so now we have an experience here that allows us to realize that doubling the height of a cylinder only doubles its volume.
Right.
But doubling the radius of a cylinder, since it's an r-squared
Since you
term,
square it.
is going to cause the volume to quadruple.
That is terrific. That's a great example of
And
that.
so this is a good way to
demonstrate that
right,
with a
yeah.
practical experience.
And you get interest going with a hands-on activity
A
like
lot
that.
more interesting than just the equation on the board. Nice to have you here today.
Well,
thanks for coming. I'll try to get the salt off before we come back. We'll be right back.
Wash this right off.
Wash this right off. We'll be right back with news and weather right after this.